Okay, we'll talk about inheritance and polymorphism in this video. So inheritance, a key object-oriented concept. Again, we assume that students of this course are familiar with OOP, and this is more like a Java overview. So we won't go deep into what inheritance is, but essentially inheritance is a way of reusing some code where you have a class which has a certain fields and certain behavior, certain data and certain behavior, and you want to reuse that. So you extend it. You By extending, you get all the data and all the behavior, and then you can do these two things in that child class. You can add a new field or new methods, that way extending the behavior of that class, or you can override, not overload, override, which means re-implement the methods that you inherit from the parent class. So we'll see an example. Here is the animal class that we already saw. It has the two fields, one for name, string name, and an integer num legs, the constructor, of course, and then a run and a speak method. We'll create a dog class which inherits all of that, adds adds a field named owner, and overrides the speak method and adds a method called play. You play with your dogs, right? On the other hand, you have an extended class lion, which again inherits everything from the animal base class or the animal parent class, and overrides the speak method. We are not going to play with this lion, so we don't have that method. We could, of course, add additional methods like hunt and whatnot, but keeping examples simple for now. Okay, so here is the code for that. The animal class will remain the same from one of the previous slides. We have added the field owner as a private string owner and the constructor. Now the constructor takes a string for the dog's name and a string for the owner's name, and let's see what it does. So it calls a method named super, passing it the name and 4. What does this mean? So super here invokes the super class constructor. Remember, the super class animal has a constructor that takes the name of the animal and number of legs. So all dogs are going to have 4 legs. So we can pass a 4, and we pass the name we got for the dog onto the superclass constructor. Then we use the owner parameter to name the owner of this particular dog. We are overriding the speak method. In Java, you use the @override annotation to specify overriding of the method. And now we simply print woof. A brief note about print: there is no method print as it is, standalone in Java. But just to keep our slides cleaner, somewhat clean, let's say, the system.out.println is replaced with print this point onwards. So the dog now speaks woof when called. And this is the new method that is added, play, and there we print, I can fetch a ball. Okay. All right, now let's look at the lion class. The lion class also extends animal. Its constructor, there is nothing different to do here. So we simply call the superclass constructor by passing it name and 4 for number of legs. Again, all lions will have 4 legs. And here, once again, we override the speak method to print roar in case of lion. Okay. So this is the syntax for inheritance for extending classes. Next, let's see how to use these extended classes. So you can do something like dog, give the reference some name, let's say lowercase dog, then equals new dog, Milo for the name of the dog, and Stanley Ipkiss for the owner of the dog. Um, if you have watched the movie The Mask, um, and then we create a lion object using new lion and pass it Simba. Now note, lion's constructor only needs a name for that particular lion, and it's going to plug in 4 by calling the superclass constructor itself. Right. Let's see what happens to the method play and speak, etc. So if we now, after creating the dog and lion objects, if we call dog.speak, it will print woof, because this method is going to map to this particular implementation. Similarly, if we do lion.speak, it's going to say roar, because that maps to this particular implementation. Now, how about lion.play? It will result in an error. Let me pause, and I suggest you just think for a second. Will it be a compile time error or a runtime error? Answer is it is a compile time error because the method play is not available in the lion class at all. The compiler cannot find the method play over here. On the other hand, dog.play would compiler will be able to find this method and execute it and print I can fetch a ball. Now, food for thought, what happens if you do a lion.run? The run method is not here. Will that be a compile time error, or will that be something else? To find the answer, we should go back to our inheritance diagram. See, run method was defined in animal, and that is inherited by both dog and lion, and not modified at all. So even if the dog and lion class don't talk about the run method, they have it because they have inherited. So this is not an error. It will go and execute whatever that run method says. I think it prints, I'm running with these many legs. So that's what we'll get. The other important aspect of object-oriented programming is polymorphism. So polymorphism, briefly, is when objects of a given type can have different behavior at runtime. So in this example, we'll see how we can create an animal who behaves like a dog and an animal who behaves like a lion. But it will be animal for many other purposes. So this is how you create it. You can say animal A1 equals new dog and give it appropriate parameters. And then animal A2 is a new lion and give it appropriate constructor parameters. Now the key point here is the type of A1 or A2 is animal, as in the static type, the type that the Java compiler looks up at compile time is animal. What that means is you can call all the methods on A1 and A2 that are available in the animal class. You may be asking, what is the point of doing it this way? One major advantage is you can use the static type, which is also called the declared type, as a type of parameters of methods to which you want to pass these objects, or the generic types for collections like lists. So suppose you want to create a list of animals. All the dogs and lions that are created can go and fit inside the list of animals. On the other hand, if you created a list of dogs, lions cannot fit into that. So, for methods or such collections in which you are only interested in the common operations, doing it this way is a good idea. Next, let's see how or what methods we can call on those. So here, if you do a1.speak, it's going to it's going to find that the implementation of the speak method was in the dog class, which is the actual dynamic type of A1, and it prints woof. Similarly, A2.speak will be able to go and find the implementation in the lion class and print roar. So this is the polymorphism aspect. I mean, A1 is also an animal, A2 is also an animal, but at runtime, they behave differently from each other based on how the objects were created and not how the objects were declared. Now, what happens if we try to call A2.play? Similar to the example on the previous slide, lion does not have the method play, so it will not be called. It's a compile time error. But think about this. What should happen if you try to invoke A1.play? A1 is a dog, and if you call the method play on that, you have the method play over here in the dog class, and you'd expect it to execute. But that also is an error. Why? Remember, Java is a statically typed language, and when you type a1.play at compile time, it's only going to check what is the type of A1. It's an animal. Does animal have the method play? No. So it gives us a compile time error. So this is a very tricky part about Java polymorphism, and many people get confused about it. So make sure you understand this. In Android programming, we are going to use a lot of inheritance and polymorphism. So this may trick you up later as well. So make sure you understand this aspect of Java polymorphism. Okay. So, we said Java is a fully object-oriented language, and like many object-oriented languages, Java supports what's called a cosmic superclass, a class that is a superclass of all other classes in Java. And that one in Java is called object with the capital O. So an object class, whenever you create a new class, let's say new game or a new vehicle, you don't have to say extends object, but that automatically happens for you. You're going to inherit everything from the object class. This is a good design because you can get certain common methods on all your classes, and some of those common instance methods that are inherited from object are the toString method, which is supposed to return the string representation of the class. So typically you would override this method to show the elements of your class. So let's say you have a student class, your toString implementation can basically be a string concatenation of the first name and last name of the student, maybe their current grade, their address, or whatever other relevant information is. The second one is the equals method. Remember, we talked about this very briefly in the discussion on operators. String and any reference classes, I said, should not do equality comparison using the double equals operator because there, with the double equals operator, Java is only comparing the addresses, the reference values of the objects, and you want to look inside the objects and look at what are called their object values. So for that, you should override the equals method in your classes. The equals method takes an object as an argument and returns a Boolean telling whether the passed in object, the other, and this object, if they are equal for the purposes of your program. The third common method, perhaps less commonly used than these two, but for a proper implementation of equals, this should be overridden and implemented as well. That is the hash code method. This converts the object value to an integer so that it can be used in hash tables. Okay? Again, we won't go into the details of this over here. Students are expected to know the basics of these, but these are the three I mean, the concepts of these outside of Java, these are some of the commonly used object class methods. Next, let's talk about abstract classes. So in the examples above, the speak method was re-implemented by both the dog and the lion. And you can imagine, no matter how many animals we create, each of them will have its own sound. So we'll be re-implementing the speak method again and again. So if that is happening, what's the point of implementing it in the parent class animal? That's a legitimate question. You don't want to implement the method unnecessarily. There are 2 points related to this. So one, if you have it implemented there, one of the later classes down the inheritance chain can, by mistake, miss re-implementing it for that particular animal, and then it will continue to have the default behavior from the animal class, which is perhaps not a great idea. Could there be a check, ideally a compile time check, which tells you that you have not implemented this method? So before answering that, let's see what can happen if you remove the speak method from the animal class. If you do that, then you lose control over calling the speak method on an animal object. So going back to the example of a1.play on the slide of polymorphism, if the animal class does not have the speak method, Java cannot check at compile time when you are invoking that method, and you'll get errors. So you must have a way to call the speak method, but also a way to enforce implementation of that method in every child class. So how do you do that? A way to solve this problem is using the abstract methods. An abstract method is simply a declaration of a method without having an implementation. And then an abstract class is a class with at least one abstract method. And as you can perhaps imagine, an abstract class cannot be instantiated. So let's look at an example. Yeah, so here is a modified animal class with the keyword abstract in it. We'll keep all the fields and methods except the constructor now, because you cannot have a constructor for an abstract class. Now what we see here is an abstract method speak with no implementation. So when a dog extends animal, it has its own fields or other methods which are overridden, but it also has to override the speak method by, say, printing woof. If you do not implement the speak method, you will get a compile time error. So both our problems are solved now. All child classes are forced to implement these methods. This mechanism provides a single point of control, which is a great design principle. Let's see how to use it. If you try to create an animal A, say a new dog, Abu with 4 legs, and I think I carried over the example of constructor from the animal class, but I hope you get what I'm trying to say here. You create a new dog object and call speak on it, and it comes over here and prints woof. What happens if you try to create an animal object? Now that won't be possible because animal is an abstract class. A special case of abstract classes is interfaces. So interface is a keyword in Java, and an interface is basically an abstract class in which all methods are abstract. Slight changes in Java 8. Java 8 introduced what's called a default method, and you can implement the default method by giving it a keyword default in the interface itself. There are certain reasons for why they did this. We won't go into those methods here, but if you're interested, you should look up and see what the default keyword does. Okay, you cannot have any declared fields, and of course no constructors in an abstract in an interface, sorry. When a class extends or inherits from an interface, instead of the extends keywords, in Java, you have to use the implements keywords. Another important difference is Java by default does not support multiple inheritance. So you cannot, your class C cannot extend class A and class B at the same time, but it can implement multiple interfaces at the same time. Let's look at an example. So we are going to create this hierarchy of birds where the bird is an abstract class. It has a wingspan. It has a Boolean to specify whether it's a nocturnal a bird or not. And then the constructor, and once again, the speak method, which is an abstract method. In addition, you have interfaces, a flying interface, which provides the fly method, provides as in it gives the declaration, but not implementation. Hunting interface gives the hunt method, and swimming interface gives the swim method. And then we'll see we create two concrete classes, a pigeon that extends the abstract class bird and implements flying because pigeons can fly. And it overrides the speak method. And of course, it has to implement the fly method. Then we create a class hawk, which again extends the bird abstract class and implements flying as well as hunting. Similarly, we can have later on, say, a duck, which implements flying as well as swimming. But let's just look at the pigeon and hawk example for now. So here is the abstract class bird. Nothing quite special over here. And these are the different interfaces. So this is how you use the keyword interface. All right, now let's see. The pigeon class extends bird and implements flying. That is the only interface it's going to implement. Constructors and other fields are not shown, but we see it speaks coo by overriding, and it overrides the fly method, implements the fly method by saying, I'm a good flyer. Now the hawk extends bird and implements flying as well as hunting. We can specify the different interfaces it implements by separating them with a comma. Again, constructors and fields are not shown, but it speaks by printing screech. It implements fly, I am a great flyer, and it implements hunt, I hunt small animals. So this is how you can use interfaces in Java. Okay, so this was about the core object-oriented principles in Java. We'll again pause here and come back for some other aspects of Java in the next video.